This video is all about mileage versus voltage that you get on a solar P1 3.0. The Excel plot I'll be talking about in this video is on the screen showing the transfer function of mileage versus voltage. In the upper left corner of the screen, you'll see a video, and that's the ride that I was using to collect the data in the orange plot, the orange data points. And in the lower left corner of the screen is part of the ride that I had in eco mode, taking the data, which is the blue data on the screen. Okay, this is a plot of transfer function for solar P1 3.0, looking at the x-axis mileage and the y-axis battery voltage. So what I did was I took data points. For example, if you look at this orange line, I took data points wherever you see these dots, um, as much as I could, uh, about every mile or so. And this is driving over all different terrain. I'll put, the video up so you can see where the conditions I'm driving on. It's hard to detect the hills on, looking at the video, but this is going various speeds, and I think I had a top speed of about 32 miles per hour. Most of the speed is probably around the 12 to 15 miles per hour sort of range. Going up, it's a lot of hills. They're about 6 to 8 degree slopes, so not massive, but it's meant to monitor kind of real world use, or at least the way I would normally use it. And when I take all these data points, then I can plot this trend line, which is this dotted line. And I just used a linear trend line to get an easy linear function, right? So if we look at that, the x-axis again is mileage, and the y-axis is volts. So, at 0 miles, a fully charged P1 3.0 scooter is going to be 59 volts. Okay, so every data point is going to start from here, and then the slope is going to depend on the weight of the user and the kind of driving that you're doing, what kind of terrain you're on. If you're on hills, for example, if you're driving full speed, that sort of thing. So, this is generally what I'm going to get. And so I can look at that, and let's say I'm riding and I turned off the key and my trip odometer got reset, and I have no idea, how long I've been riding. So I don't know, uh, you know, if I'm going to be able to make it back on my battery voltage or not. So I can look, for example, and say, okay, well, I'm at 54 volts here, um, and so I'm going to be able to get another 10 or 11 miles before you know I'm running out of battery power and not able to really ride normally. So, you know, by knowing basically for every mile, uh, I'm going to need about 580 millivolts of battery power. That allows me to estimate, uh, how far I can go before I get stranded. Okay, so I took these orange data points here. I took it all. I'm in S mode, full launch mode, full regen, and me and my gear is about 265 pound. So that's my load conditions. Now, when I take each data point, I stop the scooter and give it a second, and then write down the voltage and my mileage. So that's under no load conditions. And I do that because if I'm riding down a hill or something like that, or up a hill, that's going to put some voltage sag, because my motor's taking some current from the battery, and so the voltage is going to sag a little bit, and it's not going to give me an accurate reading. So I come to a full stop and then take the reading. Um, so that tells me, you know, it's not the data is not going to be impacted by the train I'm on and giving me uh, readings that are too far off. Now the readings are going to be a bit noisy here. You see some jumping around. Sometimes you sit for a moment, and this could be even regen breaks. I have to test that a little bit to see how much of an impact it has. But you sit for a minute, and the battery may actually rise a little bit as things cool off, and you know there's no load on the battery. You may, if I take a 30-minute break, for example, I may come back, and even though I haven't went anywhere, my voltage has jumped up a little bit. So, but that's okay because I'm just doing a best fit line here. And so taking all these data points, this best fit line is basically averaging out any of that noise. Okay. Now the blue line here, I took some data, but this time I was in eco mode, which is what I would normally ride in. And, similar sort of terrain. So, and same load conditions. So there's really not any significant difference. The only difference between eco mode and S mode is going to be if I was driving faster, right? But if you're going the same speed, then either one of these modes, if you're doing 10 miles an hour, for example, it doesn't matter if you're in eco mode or S mode, you're going to get basically the same transfer function of your voltage versus your mileage. Okay, so as we go and we look at this transfer function, it's mostly linear. I could probably get a better fit if I did a polynomial fit, but then, that makes it, if I'm sitting out there and trying to figure out if I can make it home or not, I don't want to really deal with a second order function and, just a simple, okay, 580 millivolts per mile. That's good enough for me to estimate. But you notice when you get around 49, 48 volts, you drop below that, you get in this warning zone where you're not getting this, linear transfer function anymore. You're falling off a cliff. And so in this warning zone, you're going to be losing power. You're not going to be able to climb hills as well, if at all. Um, and eventually you get to the point where the scooter's going to be completely dead and, you're not going to be able to do anything with it. So it's important to know where the performance falls off to make sure that you don't get stranded. Okay. So now, so looking at all this, I can get somewhere, in this, pushing it all the way. I could get about 21 uh, miles with the 265-pound load on the Solar P1 3.0. Now, this is just from one data point. I took a few data points and averaged them, and in real world, I'm getting about 22 miles. That can be different depending on, different loads on the motor, which can be, maybe my gear is a little bit lighter one day, but probably the bigger thing is, uh, not driving as fast or hills particularly. So, you're going to get some variation around that. So on average, I'm getting, as a 265-pound rider, I'm getting about 22 miles on the Solar P1 3.0. So how can this help somebody else? Well, if you're a heavier rider, everyone is going to start at the same point. You're going to get fully charged 59 volts on the scooter. It's going to be some variation scooter to scooter, but basically you're all going to start from about the same point. And what that means is you're going to have a gain error or a different slope depending on your load. So if you're heavier than 265 pounds, you can expect this to slope more downwards. If you're lighter than 265 pounds, you can expect this to slope upwards. So a lighter rider should get more miles, a heavier rider should get less miles. Now, these are just illustrations. I don't know at what load condition it drops to 14 miles, and I don't know under what load condition it goes up to 25 plus miles. Um, but it's just to illustrate what you can expect depending on your load. But since this is fairly linear until it gets to this drop off point, what that means is it would be easy for a rider to just take, maybe 4 or 5 measurements. They don't even have to do this full curve because, after about 49 volts, you're going to, you know, run into this cliff where you're not going to get the same performance anymore. So if you take a few, figure out the slope of your line based on your conditions, where you're riding at and how much your load is, you can figure out that slope and you can extrapolate that slope all the way to about 49 volts. And from there, you can figure out exactly what your line would look like without even doing the full transfer function. So I think this could be helpful to other people. Okay, I hope that was easy to understand. It's basically just, how much voltage do I need to go a certain amount of miles? Um, and that's the transfer function. And so again, here it is. This R squared factor is just basically how well does it fit? How well does the data fit? Don't worry about that too much. Uh, the y-intercept is basically your starting voltage at 0 volts. Sorry, at 0 miles, no load. And but this is what you really want: the slope of this line here, because that tells you, how many volts per mile. All right. All right. Hope this helps.